Okay, welcome back to Step Electrical friends. Now we are here again to discuss on nodal analysis, and this is the last part of nodal analysis. So this is the part 5, and in this part we will discuss on the last circuit, that is type 4 circuit. Okay, so let's see what type of circuit it is. As you can see in this figure that the voltage source is present along with the current sources. Current sources I1, I2 and I3, and a voltage source is present. But the presence of this voltage source in this circuit is different from all other previous type. Here this voltage source is lying between two nodes, this node and the next this node. So this voltage source is lying in between two nodes. This voltage source is lying on the circumference of this loop, but it is not involving with the reference. So you must have to think of, in the previous the voltage source was involving with, in type 3 the voltage source was involving with the reference node, but in type 4 in this part this voltage source is not involving with the reference. So this is the thing that differentiate between type 3 and type 4, that this voltage source is lying between two nodes and this voltage source is not involving the reference. So friends, the title of this video is circuit containing voltage source along with the current source, where the voltage source is not transformable to current source. Why this voltage source is not transformable into current source? You better know. Because there is no any resistor in series with this voltage source. There is no any resistor in series with this voltage source. That's why it is not transformable into current source. Okay. And the next thing, this voltage source is not involving in the reference node. As you all know that this node is going to be reference node, and this voltage source is not connected with this node from any way. So this voltage source is not involving this reference node. So this is the case of supernode. As this voltage source lying between these two nodes, so these two nodes are known as supernode. So in this video we are going to have the general analysis of the nodal analysis, and then we will solve a numerical as usual, and finally we will also verify the numerical with the help of circuit lab. So let's proceed. Okay friends, as you see here, as we have done in the previous how to have the general analysis, in the same way we will have, first of all we will find out the nodes. So here we can see this is the first node, this one is second, and this one is third, and this is the fourth node. So let's assume A, B, C, D be the nodes, where D is the reference node as usual. And now we have also to assume the voltage of each of the nodes. So let VA, VB, VC and VD be the voltage at the nodes A, B, C and D respectively. But here you can see VD is equal to 0 volt. Why? Because D is grounded. That's why the voltage at the node D is 0. So VD is equal to 0 volt. Okay, the main thing is that how to tackle. First of all, you can see there are three nodes which are unknown and the fourth node is known. We have never applied KCL at this node. Why? Because the voltage of this node is 0, which is known, and we have to apply KCL at each of the nodes. Is it correct? No. That's why it is type 4. So how to tackle is the measure. So friend, first of all we have to apply KCL at the super node A and C, and that's why we will only focus on the elements that is connected with node A and node C. And here we can see that R1, R2 is connected with node A, and R5 and R3 is connected with node C. The current through R1 and R2 is flowing away from the node A, and the current through R5 and R3 is leaving the node C. While I1 is the current which enters the node A and I3 is the current which enters the node C. In this way we can easily write the KCL equation combined for these two nodes as a super node. As there are three unknown values, so we must have three equations, and we have already used two nodes for the single equation. That's why we must have another equation, and that equation will be given by this voltage source, that is VA minus VC is equal to VS. VA minus VC equals VS. Why VA minus VC is the main thing that you have to think. The positive terminal of this voltage source is connected with node A. That's why we will write VA minus VC is equal to Vs. And the final thing, for the third equation we will apply KCL at node B. So friends, it can be pointed out that first of all we will apply KCL at super node A and C, then we will write VA minus VC equals Vs, and then finally we will apply KCL at node. So this is the simple step that we will follow and solve this problem. For this general analysis, we will also follow the same step. So to apply KCL at supernode, first of all we will write all the currents that enters as well as leave. So we can write IR1 plus IR2 plus IR3 plus IR5 is equal to I1 plus I3. As we have discussed earlier, that the current through R1, R3 leaves the node A, and current through R5 and R3 leaves the node C, while I1 and I3 are the current which enters the node A and C respectively. These all are outgoing current and this is incoming current. So we can write this equation. So we can write VA minus 0 upon R1 plus VA minus BB upon R2 plus VC minus BB upon R3 plus VC minus 0 upon R5 is equal to I1 plus I3. And this is the first equation. Now using the voltage source and the two nodes, we will write the second equation as VA minus VC equals VS. Why? Because the positive terminal of this VS is connected with this node A. That's why the voltage at node A minus voltage at the node C is equal to the voltage of the source. So this gives the second equation and this is the second equation. And so now friends, we have got two equations and it's the time to get the third equation. For that, better know how we will get the third equation. For third equation, we will apply KCL at node B. So we can easily write this one: VB minus VA upon R2 plus VB minus VC upon R3 plus VB minus 0 upon R4 is equal to I2. So this is the third equation. So friend, we have finally got these three equations, and with the help of these three equations, we can easily find out the value of voltage at the node A, node B and at node C. So now friends, you can see this is the same circuit. The resistance has been replaced by its equivalent value, while the value of current sources is given as well as the value of voltage source is also given. And here the voltage of the nodes A, B, C are unknown. As we know, D is grounded, that's why VD is equal to 0 volt. So first of all, we will assume that A, B, C and D are the nodes where D is the reference node. VA, VB, VC and VD, the voltage of the nodes A, B, C and D respectively, where VD is equal to 0 volt. We will apply KCL at super node A and C. For this node A, 6 ohm and 4 ohm is connected with this node A, while 6 ohm and 6 ohm is the resistor which is connected with node C. So we can easily write this one. And the total current at node A and at node C is 10 plus 8 is equal to 18 ampere. So we can easily replace with its equivalent value by using Ohm's law, and this is VA minus 0 upon 6 plus VA minus VB upon 4 plus VC minus VB upon 6 plus VC minus 0 upon 6 is equal to 18. And on simplifying, we will get 0.4167 VA minus 0.4167 VB plus 0.33 VC is equal to 18. So this is the first equation. VA minus VC equals 10. This gives the second equation. VA minus VC is equal to 10 volt. So this gives the second equation, and the third equation is, while applying KCL at node B, we will get the third equation, and on simplifying, we will get minus 0.25 VA plus 0.6167 VB minus 0.167 VC is equal to 5. So we have got three equations, and now on solving these three equations, we will get the value of VA. VA equals 50.39 volt, VB equals 39.47 volt, and VC equals 40.39 volt. So we have successfully solved this numerical, and it's time to verify this numerical using circuit lab. Okay, so you can see that the voltage at the node A is 50.35 and here it is 50.39 volt. So it is approx. And here it is 39.42 volt and it is 39.47. So it is again here correct. And the voltage at node C is 40.35, which is here 40.39 volt. So it is exactly equal. And find this video interesting and helpful, like this video, share this video with your friends, and drop your valuable comment in the comment box. If you haven't subscribed this channel yet, please subscribe this channel. Hope to see you in next video.